Hi, everybody. Welcome back. Topic 12, workstation design, and subtopic 12.2. So 12.1 was about physically interfacing the human with the workstation, and this one is about some visual and cognitive considerations for how a workstation is designed and distributed. So we've got our 6 here in workstation design principles. We covered the first 4 in 12.1, and we're going to talk about visibility and line of sight and component arrangement here. Okay, so this is a little bit of a throwback to our topic 2 vision, but there is a kind of a fundamental sweet spot for where to put things so that humans can look at them. And so we call this the normal line of sight. Maybe also remember the primary field of view. Those two kind of go together, not the same thing. A normal line of sight is kind of describing, well, where do our eyes naturally fall? If I was in a completely dark room and I couldn't see anything and I just was maintaining a neutral expression and having a relaxed position where my eyes are pointed, it's probably going to be in this normal line of sight. When we're standing, this is about between 0 is the horizon and 10 degrees lower than that, so you can see while standing. And if I'm seated, we tend to have a slightly lower normal line of sight, so between 10 and 15 below while we're seated. And then in general, we have to consider things like the limits of the macula as where we can get, we can differentiate hues, right? We need to have color vision. And so if you go, this doesn't quite match up with the figure, but in general, plus or minus 15 degrees on either side of the normal line of sight, maybe a little more in each sense. But the design here, you can say plus or minus 15 to get to basically where you expect that within this range. If I have a color indicator pop up, it should be visible and differentiable, to my human user. But then, of course, the most valuable space is right there at our normal line of sight. That's where you want your most critical, your most important display elements to be. Also, this is a map that I used to show a lot with the topic 2 when we talk about the distribution of retinal receptors. But this is basically a map where you see the white region is representing density of rod and cone cells. And you'll notice that the distribution of these is wider than it is tall. And so this kind of makes sense with a lot of the way our world works, where we consider things on a wider horizon than we do on a vertical horizon, I guess. And so, so we have this sort of a shape to most of our digital displays, TVs, etc. And that makes sense because it fits the rough shape of our field of view. All right, so I mentioned in the previous topic I was going to bounce a little bit between our 1472s. And so here's another example of where I found some things that were cut out of 1472G, but I still wanted to make sure you saw and could understand the details around these recommendations. So I re-included it here, page 89. You can go there and read more on, in the text about describing these. But these are just a couple of design, standards to consider. If we're using head-up displays, you remember that was a special type of display. Remember this, like in the when I'm driving my car, I can have the projected speed limit, on my windshield. There is, so here's our design standard for that. The field of view should be, not less than 6 degrees above the horizontal, 5 degrees below the horizontal, and 12 degrees to the left and right. So it's a little bit different than the normal line of sight, but again, a head-up display is meant to be not head down in your normal position, but up a little bit, okay? So closer to the horizon line in that case. The luminance ratio, which we know how to measure now, how much light is being emitted from my luminous display versus the surroundings. And so here you go. It's design standard says we want a ratio of 5:1. So you want your computer screen to be 5 times brighter than the surroundings in order for you to be able to, to clearly know what you're focusing on and not get, distracted too much or have too much time, differentiating or seeing detail with contrast. Also consider the sources of potential glare. And so if there is a reflective surface that could reflect light, obviously, it should not be within, should not be within 60 degrees of an operator's normal field of view. So if you could define that here, I don't want it 60 degrees up, down, left, or right. I want it outside of that range, if we can help it. And again, so here you can see the two differences. So 1472H has these, 72G has these. I think they're complementary. Okay, so the reality is our future is computer workstations are going to be there for foreseeable future, okay, in some form, and luminous displays. Now they may end up being, in the future holographic or some other sort of, visual representation. But in general, yeah, we can expect, and we couldn't do this 20 years ago, but today I think pretty much most workstations got to have some sort of computer element to it in order for the work to be done. So we want to think about where is that monitor, because it should be one of the primary sources of our attention, right? So you have to think about the different lighting conditions under which you will be viewing them, maybe dark, maybe light. You have to have luminance ratios that work for you there and adjust maybe to the lighting. So a lot of like my phone and a lot of computers have light sensitive adjustability, and that's basically changing that luminance ratio so that your eye will be able to pick up what's being displayed. We also have to think about the position of these displays based on what are people wearing on their eyes. Is it glasses, or do I have safety goggles on, or do I or am I wearing a headset or a helmet, for example? So that that matters. I may have to have, hey, here's my notes with me. And so maybe I want to put those in a location where I can compare back and forth, on my screen. And maybe I just have a personal preference. Do I prefer to do my Excel work on the left monitor or on the right monitor? And there'll be differences between people for that. And so you may, you may, and I say Excel work, a lot of times I'm doing something where I've got Excel and all my data here, and I've got what I'm writing about here. I'm writing about the data here. And part of that is because, at least I think this is a little bit of hocus pocus, pseudoscience, but I do it anyway. We have left brain, right brain, and basically our mathematical computational aspects are processed on the right hemisphere. Therefore, I put my Excel stuff on the left, because that's where, remember, in the visual cortex, it's actually inverted. So left side of space is processed on the right side of my visual cortex. Similarly, verbal sorts of language, the Broca's area, etc., on the left side, on the left hemisphere. And so putting on the right side. I don't think that's really worthwhile, but I do it anyway. Trick myself. Okay. A little bit of a callback. Now we talked about this in depth, so this is just like, I'm just going to hit on the high points again and say, remember when we talked about this? But where we put displays matters not only for visibility purposes, but cognitively. So if I need to look at that display, and then there's always another display that I want to compare it with, think of the proximity compatibility principle. They ought to have high display proximity if they have high processing proximity. So obviously an aircraft cockpit has a whole lot of data to display, and the arrangement of these displays is a very challenging problem to get exactly right. I think they do pretty well with it, and there's a couple examples coming up here. So again, we talked about the primary visual area. I alluded to it earlier. This is also something we went into detail in topic 4. You can go back and check it. But again, remember, what we just introduced here is that you maybe have a slightly different normal line of sight and focus area, therefore, if you're standing or seated. Okay, so 10 to 15 degrees below the horizontal plane is where our normal line of sight goes. So, think about driving a car, and where do your eyes go? It's typically on the roadway in front of you. And so, not very often are we focusing our attention above the horizon. Okay. Now, primary visual area, the most valuable space. That's where your most important data or displays go. Now, what goes next to it? So now we want to think about the other display elements or the other data sources that are commonly used in conjunction with whatever's in the primary visual field or the primary visual area. So 2 dimensions we think about are, how often do I go from this display to that display? And the more often I do that, the more valuable it is that they're close together. And how important is that other display? And so we want to consider both of those, how often and how important. And if it's both often and important, then that makes it an easy choice. But if it's one or the other, sometimes there's trade-offs you have to think about. Think of the sequence of use. If I'm going to look at this one, and then if I always look at altitude and then airspeed, put them right next to each other, put them very near to each other so I can find them. It provides an easy, an easy transition in, a saccade, a shift of my visual attention. And so when that's faster and easier to find, the whole thing moves smoother. Proximity compatibility principle, again, don't forget that. It keeps coming up. So yes, we talked about it in the first half of the course. Yes, you took a midterm on it. But if you remember, I did say that the final exam will be not entirely after the midterm. There will be some comprehensive aspect to it. This is a good example when I keep hitting on this proximity compatibility principle because I love it. Might see it again. So, make sure you didn't flush that from your brain after the midterm. Good. Consistency, another principle we have talked about in the past, especially when people are stressed out, they revert to familiar things. So if I get in a rental car, if I get in a Tesla, which I don't own and I've never driven, so that's like what this is. I think this is a Tesla. Yeah, it is. And now my windshield wipers are a touch screen enabled control. I don't know if that's true, but in my car currently, where are my windshield wipers? Right here. They're right there on the knob next to the steering wheel. And that's where I might expect them to be. So suddenly I get in this Tesla and I'm driving, I'm rented it in some place, maybe London, and I'm driving it. And now I need to turn on the windshield wipers. This is a bad example because I'm using Tesla as the example. It probably auto senses and turns them on or something. But you can imagine, again, if I want to activate a certain function and I find myself in a location where, or, a situation where I got to find my, my windshield wipers, my headlights. I got to figure out, I think I probably mentioned before, the times when I've had a rental car and then tried to figure out how to open the gas tank at like 3:30 in the morning on the way to the airport, so I could refill the rental and can't figure that out. And I have been in that circumstance. So having consistency in where I expect certain functions to exist, certain controls to be, helps a lot, especially under stress. I think I've shown these figures before, but just as another example, the FAA, the Federal Aviation Administration, has, the 4 most basic flight displays are basically mandated, I suppose, to be arranged in this T block, or sometimes they call this a 6-pack sometimes, but maybe the 4 main ones are always arranged in this T shape. And then when we go to this digitized glass cockpit, as opposed to the, the old school, steam gauges, so to speak, or the mechanical sorts of, the mechanical scales and indices. Now we go here, we have the same, arrangement. And that's great because if I'm flying this plane and then I fly this plane and I want to know, do a common instrument scan, I can find things without having to look for them too much. Okay, so and then on the last sub of this subtopic, we're going to talk about controls and where we put them to support sort of cognitively what you're going to do. Controls, or let's call them like materials that you may, physical materials you may need to do a task. So it could be, raw parts, bolts, screws, work pieces. It could be various, buttons, controls, yokes that you need to, be able to access and interact with. So I'm just calling all of these components just to be a little bit more generic. And if you can think of displays as, it's important to put those next to each other because I got to move my eyes and reorient and get the next information. And when that's a short movement, it's easier. Similarly, if I'm physically picking up that screw, then this screw, then this screw, and then putting them all together, having them co-located in a common location helps a lot for that. The things that are most frequently accessed, like our snacks at our workstation, we gotta have our snacks, right? I don't have any good ones here, but cranberry juice, why not? So the frequency in which we will access those components, the more often we need them, make them closer to you, you're gonna save that much, per reach, you're saving that much effort and search time, let's say. So we can consider then if it's a something that has to be seen, primary viewing area, and we also have to consider our reach envelope. Can we get our arms to it? The importance principle. So these are all design principles to consider if somebody says, how are you going to arrange your components? So this is a nice figure that you could refer to here. The things that are most important to do, think like driving a car. Where do I have the steering wheel? Right in front of me, my primary control space, right? So the most crucial things are not ones that you have to reach for. They are the most naturally where your controlling limbs would be. Sequence of use, I kind of already alluded to this. If I've got 3 different parts I have to assign, assemble together manually, putting those 3 parts right next to each other makes that job a lot easier than I got to get this one here, that one here, and this one here. And if you have the chance to arrange your own workstation, I would recommend you think about that. Well, what do I commonly use, in sequence? For example, if I have to print something, I don't know if any of you have, printers at your home office, for example, if very commonly you have to get out paper or maybe even check for ink or something and put that, put it in. I'm doing a sequence of steps to print something out. Put all that printer stuff in the same location. It'll make your life a lot easier. Don't do like my wife and store the printer paper in the box over there, because otherwise it doesn't look good. Actually, all right, do it however you want. There's going to be sometimes conflicts or conflicting principles. This example I hear on the right, what I'm referring to in my own house is how if I got to clean something, we have several different places where we keep the various cleaners. And there's also one place where we keep any sort of gloves or hand protectors. And so what I have done then in my house, this isn't my picture, but I have bought additional pairs of gloves and kept them in each place where I might need to use them because they're cheap. And then that way I never have to think, where are those gloves? And then just go with bare hands, and then I got to protect these guys. All right. Consistency principle, I think we've almost beaten this to death now. But again, when people are stressed, this gets extra important. When things are in consistent places, it's less of a memory burden and it's faster to find what we want. Control display compatibility, pretty straightforward. We ought to have the controls nearby their associated displays. If I do something on a control and I expect to see a change in the system, I ought to be able to observe that very, relatively easily, I should say. So again, from the natural mapping discussion of controls, these are the stovetop example. Clutter avoidance. we talked in controls about having a minimal separation between different types of controls just to be able to get your fingers in there and not bump the wrong one. And so this kind of goes with that too. But clutter is more of a cognitive thing. Like I see an entire array of controls, it makes it that much harder for me to locate the one that I want. So you have to consider that there needs to be some organization, some delineation, of these controls. Proximity compatibility principle, again, is a really great way to do these sorts of groupings. Functional grouping, if things have a common function like electrical safety, put them in a common place. So anytime I do something stupid in my house and there's a big spark and something electrically doesn't work, like what I was doing with the dryer last week, and nothing is turning on, my first step is let's go look at the input circuit breaking box here, that is designed to basically kick circuits off if there's any sort of unnatural discharge, which tends to happen when you're screwing around with things and not careful. By the way, I'm not proud of that. I wasn't being safe enough. I hadn't unplugged the dryer and I was trying to clean the the fuzz out of the back of it that had fallen down our vent. And so I took the thing off and I may have contacted one of the live wires with the aluminum casing, big spark. Then I found out that, yep, circuit breaker tripped and it's all right. But anyway, unplug things before you deal with them electrically. All right. So we got about a lot of principles here. You're not going to be able to satisfy them all. Sometimes principles are in direct conflict, like, for example, frequency of use and importance of use. I will give a good example, a fire extinguisher. You might say that, fighting a fire in your kitchen, for example, might be one of the very important things you want to be able to do. But are you going to put that fire extinguisher on your countertop and have it sit there so it's easy to reach? Probably not, because you're not frequently using it. So you have to balance those two and determine, which is better for my system overall. And there isn't just one answer for that. One way you can analyze this quantitatively, though, is to use link analysis. And so this is one technique that I go into a little bit in ISEN 631. We don't really practice it, but this is one of a family of methods for task analysis, where maybe you want to map out the spatial location of different tasks or the components you'd need for those tasks, and see how often you go from one to the other, and see if there are some that I keep going back and forth between, and they're too far apart spatially right now. And so this can help you quantify, which things should be closer together or further apart. And minimize the total travel time across, all the things that I may need to interact with. And we have programs that can do this for us. So if you use a link analysis method, a lot of times you can say, hey, boom, optimize this, rearrange it for me. And you could see a hypothetical rearrangement that would reduce the amount of movement time or the amount of need to reorient your attention. And so it looked like this, for example, if A, B, C, and D are 4 system components I maybe need to interact with, and if I start at A and then I more often go to D or C next than I do to B, that would be reflected by the thickness of the line. So one way you can do these analyses is to manually draw a line each time that there's a tie between those components, and make the thing thicker. The line grows thicker and thicker with each additional, sort of striation or whatever. And if this is what our system has as input, then maybe there's a way to rearrange it. And if we take those that have a thicker line between them and make them closer together, if you can kind of think of the total amount of ink as being the total amount of cost in transitioning among these, I maybe am minimizing it with this sort of an arrangement. And of course, it can get a lot more complex than this. So this is a good example where, you can imagine each of these lines represents an interaction among those components, or a need to go from one to the other in sequence. So yeah, looking at this, I might say that there are some components, probably seat B and stretcher being some of the most well linked. And so yes, those two being close together makes sense. But you might look at this and say, well, there's a couple other items that might be put in a slightly different location that's a little more accessible to, the linked components. And that is topic 12, ladies and gentlemen. Thank you. Signing off from London, and I will be back at the end of the week. Hope you all have a nice rest of the week. Oh, you should have everything you need now to do homework 11. All right, thanks. Bye.